All right, this is Module 3, Lesson 6. We're going to talk about angle sum of a triangle and then exterior angles of a triangle. So, in this opening exercise, we're going to answer these questions to prove that the sum of the degrees of the interior angles of the triangle, that means all the angles on the inside, are equal to 180. When you add them all up, they should equal 180. So, before we begin this, let's take a look at this rectangle. We're going to have to label it so when we talk about it, we know what we're talking about. So, let's label each of the corners A, B, C, D. So we're talking about triangle or rectangle A, B, C, D. All right, so what is true about the 4 angles in this rectangle? Well, if we know it's a rectangle, we know that every single one of these is a right angle. So that means all 4 angles are right angles. So that means they're all equal. They're all 90 degrees. So what is true about the sides of the rectangle? We know that this side over here is congruent to this side. Remember, we can use 1 tick mark and 1 tick mark. We know that these sides are congruent. Okay, so we know that the opposite sides are congruent in length. All right, next step. It says, let's draw a diagonal that connects A to C. So let's draw a diagonal. It's not very straight, but A to C. We could choose B to D also, but I just chose A to C. So what shapes are formed? You notice that there are now 2 triangles. Are these triangles congruent? If so, let's prove it by naming the transformations that map one onto the other. So what transformation can I do to map this triangle onto this triangle? All right, if you rotate them, then this side is going to be equal to this side will be equal to this side. So yes, they are congruent. Okay, you can rotate 180 degrees completely upside down, and then you're going to have to translate to the right a little bit to map one onto the other. You want to get them on top of each other so that you can show that they are the same, they are equal. So what is the angle sum for the whole rectangle? So the whole rectangle has 4 right angles. If you need to use your calculator on this, that's 90 times 4, which is 360 degrees. That's for the whole rectangle. So since the rectangle is made up of 2 congruent triangles, 2 triangles that are equal, each will have exactly half of the total degrees of the rectangle. So since they're both equal, it would just be cut in half, which means 360 divided by 2 gives us 180 degrees. So each of the triangles will have 180 degrees in their angle measure. All right, so let's go to the next page. It says, let's take a look at what's called exterior angles of the triangle. So those were interior angles inside the triangle. These are exterior angles, which is when one of the sides of the triangle is extended. And you can see the picture here. Each of these is the exterior angle when you extend one side of the triangle. So what do we know about the sum of interior angles of the triangle? We just talked about this. We know that all 3 angles will add up to 180. So the sum of interior angles will add, well, I guess if it's a sum, that's telling us that it's going to add. So it will be 180 degrees. So let's identify the 3 interior angles here. Okay, I'm going to use the points. So this would be CAB. So CAB is one of the interior angles. CBA is another, and the last would be ACB. So those are the 3 interior angles that would add up to 180. What do we know about the degree of a straight angle? Well, the straight angle has a measure of 180 degrees. So let's look specifically at straight angle ABD. So ABD, it's this angle right here. If that's 180 degrees because it's a straight angle, what two angles make up this straight angle? Well, it would be ABC, this angle right here, and angle CBD, this angle right here. Those two make up the straight angle, which means that they add up to 180. So the triangle and the straight angle both have measures of 180 degrees, inside and the straight angle. So we can write them as that they are equal to one another. So let's do that. We have angle CAB plus angle CBA plus angle ACB. Those are the three interior triangles, okay? Interior angles that I got from up here. That's going to be 180 because you add them up, they equal 180. These two angles, ABC plus CBD, those are the straight angle, which is also equal to 180. Since this is equal to 180 and this is equal to 180, those are equal to each other. So I'm going to say CAB, CBA, and ACB is equal to ABC and CBD. So since that is equal to that, okay, what angle is common to both the triangle and the straight angle? So what angle is common? Now, ABC is the same thing as CBA. So that would actually be our common angle. So that's on the next page. I'm going to answer that. So I'll say ABC, but just note that that is the same thing as CBA. If we subtract that from both sides, what do we get? So I'm just going to rewrite what we had from the other page. That was CAB plus CBA plus ACB equals, we had ABC plus CBD. Okay, so if we subtract that from both sides, we're going to subtract angle ABC from this side and ABC from this side. Remember, CBA is the same thing. That means those two cancel out. We have angle CAB plus angle ACB is equal to angle CBD. That's what we're left with after we subtract. Now it says, what kind of angle is CBD? So let's go back to our diagram. CBD, this angle right here, it's already labeled. It's called an exterior angle. It is an angle on the outside of the triangle. So we call BCA and CAB the remote interior angles because they are furthest or remotest from the exterior angle. So these two angles right here are called remote interior angles. And it's because it's furthest from the exterior angle. So now if you look at this, we're talking about BCA, so this angle right here, and CAB, which is this angle. Those two are furthest from the exterior angle. So this equation that we just came up with right here means that the sum of the remote interior angles, the ones furthest from the exterior angle, is equal to the exterior angle of the triangle. Now, this sounds really, really complicated, but it's really not. So let's look at a diagram. It says find the measure of angle X. So this is an exterior angle. Okay, so that means that this exterior angle is going to be the sum of the two that are furthest away. So not the one that's right next to it, but the one furthest away. So X is going to be equal to 30 plus 14. 30 plus 14 is 44. So this angle is equal to the other two angles added together. All right, I'm going to have you attempt this in the problem set, just using that formula that the exterior angle is equal to the two remote interior angles added together. go ahead and try that problem set on your own. We'll go over that in class tomorrow.